Steel frame buildings are broken down into two categories, representing variations in materials and methods, which allow for greater application flexibility, ultimately providing opportunity for increased value and efficiency across different building types. So what is a pre-engineered building? It is a building supplied by a single source company that does both design and material manufacturing. Their in-house engineers design buildings using the standard line of materials produced by their manufacturing side. These two divisions come together to provide a complete building shell package from a single source entity. They're typically characterized by low-sloped roofs and metal roof and wall skin. These buildings have a wide range of uses, but because their sloped roof system allows for larger clear spans, the most common is applications such as warehousing and auto repair facilities, where columns within the floor space would be a problem for maneuverability. Pre-engineered buildings are designed for efficiency in their assembly. To do this, they utilize columns and beams for the main structural elements and C or Z-shaped purlins for the secondary structural support of the roof and wall skin. Now, to make the assembly even faster, all these elements are bolted together. Now, there is a downside though. All this design efficiency does produce a negative byproduct. These buildings lack flexibility for customization. Now, this isn't to say that they can't be customized, but the more a pre-engineered building is customized, the less cost-effective it becomes. You can think of this kind of like buying a car. You can go to the Chevy dealer and pick from a pre-designed line of trucks, and you can add additional features to that truck to customize it the way you want it. But with each feature that you add, it increases the cost of the truck. And at the end of the day, once you get done with all those added features, more than likely there's still going to be somebody out there that has a truck just like yours. Now, if you want a one-off truck that nobody else has, you have to go to a custom car builder and have it built to your specifications. But, as we know, a car like this is going to cost a lot more money than going to a dealership where they manufacture in mass quantity. Pre-engineered buildings are exactly the same way. At some point, you lose the value of the pre-design when you start customizing. And at that point, you might as well just go to a conventional steel frame building where you have the flexibility to customize whatever you need to. They are a one-off, individually designed structure for a specific use. They're typically made up of columns and beams, just like a pre-engineered building. Those beams are for the main support structure, and they have open web bar joists as the secondary structural components. The bar joist will support a corrugated roll-formed sheet metal decking, and this decking will provide the support layer for the roof membrane, which, incidentally, is supplied and installed by a separate contractor. In the application of a multi-story structure, typically there would be a similar type metal deck that would support the floor system for the building, which is oftentimes a concrete slab. And once again, just as with the roof membrane, that concrete slab would be installed by a different contractor than the steel frame contractor. You can quickly begin to see how a conventional steel frame building can be much more complicated than a pre-engineered building. Let's kind of look at this comparison from a graphical perspective and evaluate the levels of involvement related to both of these building types. Both systems will require the use of an architect and a structural engineer. Now, I know I said earlier that a pre-engineered building is designed by the manufacturer, but you still need an architect and engineer to design the other elements of the building, if you will. However, because they're designing less elements, their level of involvement becomes lower for a pre-engineered building. Both buildings will require a general contractor to manage the entire building project, but his level of work will be lower, and we'll see why here in a minute. Now, for comparison's sake, we'll break out the steel frame of each building. On the pre-engineered building side, the manufacturer will hold a larger portion of the project pie because he is supplying not only the structural frame, but also the roof and wall skin, the insulation, and doors. On the conventional frame, the steel contractor will only be providing the steel structure. All those other elements that are provided by the pre-engineered building contractor will come from different trades. So as you can see, on the conventional steel side, there are a lot more people involved in the whole process than there are on the pre-engineered building side. So going back to the GC's responsibilities, you can now start to see how his work is cut down on the pre-engineered building because there are less people to coordinate and manage. The conventional frame structure is going to require a lot more of the GC's attention, both on the design and construction side, because of the complexity of the delivery method. Essentially, there are more people taking a piece of the pie, which means the supervision is greater to make sure everyone is taking what they're supposed to. It would seem from this scenario that utilizing a pre-engineered building would be the best option, but it all comes down to the building use. Some building uses can easily take advantage of the economies associated with less customization, but many don't have the luxury of being able to utilize a standard building type.